And hello, welcome to Code Live. Today we are going to start a two-part series about AI with GPT and how can we integrate it with Salesforce using MuleSoft and external services. So there is a lot of great content that we are going to be covering in these 2 days. Before we start and before we introduce our guest, let me introduce myself. My name is Julian Duque. I'm a principal developer advocate here at Salesforce, and I'm very happy to be back here in Code Live. So let me share my screen and I will share some announcements. Dreamforce is just around the corner. You are in the United States or you are planning to come, please go ahead and register now. You are still in time. There will be a lot of great developer sessions for you to sing in, and we are preparing a lot of great surprises. So please come join us at Dreamforce. And if you are attending at Dreamforce, feel free to find me at the Developer Grove and say hi. I will love to meet you. Okay, also make sure to watch How to Dev in Salesforce Plus. It is a new show that we have that will teach you how to become a Salesforce developer. So go ahead, Salesforce Plus is totally free and you will enjoy this content that we have for you. Okay, let me show you a little bit of the upcoming streams. Next week, we will have the second part of this stream, which is integrating GPT into Salesforce. Then we will have Mohit Srivastava with how to work with the Salesforce CLI, the new version of the Salesforce CLI, the version 2 is amazing. We have a couple of AMAs, one about MuleSoft, the other one about Tableau. So make sure to sync and get more information about this. And also, we will have Mo in August 31st teaching you how to troubleshoot Apex performance and scaling issues using the Scale Center. And more content to be planned. Stay tuned. We have a lot of things to show you before Dreamforce and also after Dreamforce. Okay, so it is time for me to introduce my guest for today. Let me introduce. Oh, this is better like this. Joel Davenport. He's a lead solution engineer here at Salesforce. And obviously, Joel has way better words than me to introduce himself. So, Joe, welcome to Code Live. And please say hello to our audience and why you don't introduce yourself.
Yeah, thanks, Julian. So yeah, as you mentioned, I'm a lead solution engineer here on the MuleSoft side. My background prior to Salesforce was in software engineering and development, um, primarily around machine learning and artificial intelligence. So uh, OpenAI's ChatGPT is right up my alley, and I'm just really glad to be here and able to share this with you guys. So thanks for having me, Julian. I appreciate it.
Of course, of course. Awesome. I've been dabbling with AI, OpenAI, GPT, LLMs. I mean, since all of this hype happened at the beginning of the year, and every day I find more uses, I find more things to learn. Currently, I'm learning about chaining prompts using LangChain and vector databases. So there is a whole new world of things to learn that I have never used before. So personally, I'm very interested in this stream. I'm looking forward to learn a lot from you today, and I'm hoping that everybody that is watching us right now are going to learn as well. So tell us, what are we going to learn in these 2 sessions? What are we going to be covering in the first one? And next week, what are we going to see? And if you have something to show, let me know so I can show you the screen.
Yeah, so I don't have anything to show for the agenda yet, but
Okay, perfect.
what we'll cover on both streams really is how we build a pretty custom implementation of some ChatGPT functionality, and then how we tie it into Salesforce using external services in MuleSoft, as you've mentioned. We'll cover that next week. Today will be primarily the development of the custom API we need to do the ChatGPT interface. So
Oh,
the
great,
kind
great.
of overarching thing, we'll deal with stuff you've already talked about a little bit, but vectors with embeddings. We'll deal with some custom prompt work, although we aren't going to be chaining any today. It's not quite that complex. But that's where we're going to be spending our time today, is just the Python development, how we interact with the API, and then very briefly, I don't want to dig into this too much, but very briefly, a little bit of math and how some of this is actually going to work for us and how we're going to make this function.
Good.
So that's the high level.
That sounds fantastic. That's one of the things that scares a lot of people before getting into AI. Is there a lot of math involved? Is this super hard? Do I need to be like a scientist to do this? What do you say?
So the answer really, especially now with these APIs, is no. You don't need a tremendous math background to be effective with OpenAI or any of the other real LLMs at this point. If you're going to be building the LLMs themselves, absolutely, yes.
That's
But I
another
don't
story, of
imagine,
course.
yeah, very many of us are going to be doing that. So no, you don't need a hefty math background. The only reason I'm going to bring any math into this at all is just to explain why what we're doing works, and then we'll skip past it and move on with our lives.
Beautiful.
But that's so they don't need a ton of math for this at all. No.
Beautiful. And you mentioned we are going to be using Python. So for the people out there that have never learned Python, uh, the language is straightforward, is simple, and at the end or maybe during the stream, we can share some learning resources if you have some.
Absolutely. Yeah,
Of
absolutely.
course. Awesome. Awesome.
Yeah. Python is a very easy language to pick up if you're familiar with coding just in general.
And
It's the language of data science. So
yeah,
that's the only reason
and
we're
I've
in
been
there.
seeing is one of the most important languages on like AI development. I'm seeing
Yes.
everything is like with Python right now.
Mhm. Yeah, for the most part, Python is the most optimized in that sense for both ease of use and speed. It's a kind of a good hybrid. You can dig deeper with lower level languages, but Python's a good language for people that aren't willing to do the compiled language route.
Oh, fantastic. So, Joel, let's get started. So, do you want
Absolutely.
to share your screen now and
Yes.
start
Yeah,
with the content?
we can start right into this.
Beautiful. So, let me add your screen here. And now the
Okay.
stage is yours.
There we are. So we're going to spend most of our time here in VS Code. To start with, we have a Python notebook. So what this allows us to do is just kind of execute code, and I can demonstrate things in here. I can show you code, I can inject Markdown, and it's just really an easy way for me to present code-related stuff. The use case we're executing is actually something that I built a few months ago that provides a chat interface on top of the MuleSoft documentation. So we're using the MuleSoft documentation, which is a fairly extensive library of text files you can see here on the left. You could use any text files, any documentation, and this can be as long, as many files as you want. You see we've got quite a few documents here that we're going to be working with. But at the end, what you'll see is we can ask ChatGPT a question, and it will be able to answer based on the documentation. So it'll cite things, it'll pull things out of these files and provide us with an answer. So that's what we're going to be covering. So as we work through here, I'll just highlight things that are in the code, and Julian will jump in here and there, I imagine, to point things out and talk about stuff. So
for sure, I'm just hiding my face, but I'm here.
Yep, you're totally fine. Yeah. So the first thing, very basic stuff. The libraries we need are the important ones for us. Are OpenAI, and then we're going to be using NumPy, which is a matrix library that has been around in Python for probably a decade at least, maybe 2 decades at this point. So very basic library imports. We're not going to spend a whole lot of time here. I do want to cover what the documents look like, so I'm going to open one of these up quickly. So these are ADoc files. They're really just plain text that we had stored in our internal repositories. This is all public facing, by the way, so you can see all this documentation on our MuleSoft documentation website. So this is just a way for me to consume these without having to like scrape the internet for them. So in this case, we've got, all these different plain text files that we're going to be working with. They do need to be in plain text format for what we're going to do here to work effectively. So we'll continue moving through. The biggest thing, and we'll hang out here for a second, is we have to chunk our files. So when we send, if you've used ChatGPT for any length of time, you know that there's a context limit on how much text you can send and receive from the API or from the interface on their website. And that same type of limit applies to the embedding API that we're going to be leveraging. So we need to kind of make these documents, break them up into smaller pieces so that we can interact with the API and not get errors back. You'll notice that some of these documents are quite long, like this transform data weave here. We could not embed the whole thing in one shot. So we have to separate them out and embed them in pieces. So what this code here is doing for us is it is basically just chunking them up, right? We're going to break them into 2,000 character length strings. And then there's an overlap. The reason there's an overlap is we don't want our chunks to miss stuff that's on a line, right? So if I have a sentence that's 4,000 characters long and I chunk it into two chunks of 2,000, there might be a couple of words that, or a sentence that gets cut in half by the split. And we don't want to just completely miss the context of that sentence because it would fall at the end of one and at the beginning of another. So we have a little bit of an overlap to help us make sure we don't miss anything in our documents. And then we just break them up. So this is all we're doing here. We can run this quickly and I will just show you what these chunks look like. So it's just a very large array of documents, of like each individual piece broken up into an array.
Cool.
Julian.
I'm going to be acting as the person that doesn't know anything. So everybody
Sounds
in the
good.
stream
I like
understand this thing. The first time I approached a video, somebody like teaching these concepts, I saw this screen and it was called like Notebook or Jupyter Notebook or something like that. And for me, that was like super new thing. What is this and how folks can start like playing with one of these notebooks and what purpose does they serve?
So notebooks are a very versatile piece of software attached to Python that allows us to execute code kind of in line, and it looks like a notebook, right? The way we're going through here. So I don't have to like write up the code, save it in a file, and then execute it all as one file. I can execute individual functions. I can just execute a single cell, right? And list, in this case, list the files. But I can execute pieces of the code and debug as I go. And it's very useful for research in that aspect, right? Because I don't have to build out this giant app and then run it all at once. I can say, I want to debug this piece. Does this work? Test, test, test. Okay, it works. Now I can continue on with the variables that are still stored in the memory of the notebook. So it also allows us to we're attached to a environment here. So I have a bunch of packages installed. It gives us access to all of that stuff without the need to save like a .py file, which you might be familiar with.
Cool. And this is just a Visual Studio extension, what you are using right now.
Yeah.
Cool.
I'm fairly certain it may be an extension that I've added. I think it might be something that's standard to VS Code.
Okay,
for the Python notebooks.
Yep. If not, I already did this, but I am asking just to add context to the stream.
Yeah.
You can find Jupyter with a Y, and there is extension that you can add on Visual Studio, and it will ask you to have like some sort of Python dependencies, and now you will be able to have that support into Visual Studio Code. Okay, that was the first question. Second question, somebody in the chat is asking if you have the repository of this project so they can start like taking a look at the code while you
absolutely
go
so
through it.
I will this specific project has not been put into a repository yet. The internal one is internal, but I can share this project specifically. Absolutely, nothing in here is proprietary at all, so it can be made available when we're done with the stream.
Perfect. So we will share this at the end. We will add the link on the description of the episode when it is uploaded. So thank you very much. Now you can continue.
Yep. Appreciate the context. That's always helpful. So once we've chunked out the files like we saw a minute ago, the next thing we're going to be doing is embedding. And embeddings are a very powerful and unfortunately very rarely discussed aspect of large language models. What they allow us to do is represent a string of text in numerical form, right? So in the form that the model is going to deal with it in, we can represent it. So in this case, just to demonstrate what these are doing, I've got three chunks here that we're going to kind of see what happens. So I've got these first two are very similar. You'll notice the only difference is with a single letter there at the end, and then a fairly different one here. We're going to embed all three, and then we're going to check the distances between them. So the important thing here, you can think of embeddings like a fingerprint for a piece of text. And then the distance between the two fingerprints is how similar those fingerprints are to one another. And that similarity is what we're going to use later down the road to actually allow us to do the document search stuff that I was mentioning earlier. So just to quickly show you what this is doing, I'm going to calculate the distance between the first two embeddings and then the second two embeddings, or the first one and the third one, excuse me. We'll run them. So our distances are, 0.91 and 0.73. This is the dot product of two vectors. Not going to deal with the math right here. Just to suffice to say that the dot operator kind of provides that similarity to us. And you'll see, so these first two, embedding 1 and embedding 2, are very similar, right? The maximum score here would be 1, whereas embedding 1 and embedding 3 are less similar. So we've got a 0.73-ish here, right? The value for this dot operation can range between -1 and 1. For our purposes, the closer a value is to 1, the more similar they are. So, for instance, if I change embedding 2 to be exactly the same as embedding 1, we'll see that the similarity is very close to 1. We can round that off and call it 1 for what we're doing. There's some rounding happening inside these arrays that's going to mess this up, but it's basically 1, which means they're identical. So if two vectors, in this case, come out with a dot of 1, we know that they're identical. So back to this again. So all we're going to do is, instead of doing our demo here, we're going to take the chunks that we created earlier, and we're going to embed them using the embedding model, and then we're going to store them in a JSON object. So that's the key here, right? This is all we're doing. We're storing each of the embedding vectors here alongside the actual text that was used to create it. So we're going to have, at the end of this, a very large array of JSON objects that have the vectors and then their associated text right next to them. What this lets us do is search through our database, right? As I know, Julian, you mentioned vector databases. We're not actually going to use one because they're annoying to set up. But for this purpose, that's going to be exactly what we're going to do. We can search through a database by the embeddings, and then we have access to the associated text that generated it. So we can pull that out and work with it. And we'll get through the search function and how that works as we build out the API here in a second.
Yeah, I was going to ask if this is pretty much the fundamental concept of the vector database.
Yeah, so vector databases are just optimized ways to store these vectors. So I think one of them is Milvis, I think is one I've used. I know Postgres has a vector extension that I've used pretty heavily as well.
There's Chroma.
Really
Chroma is
an
open source one.
There's several of them. And they've really grown in popularity as a result of the AI boom we've seen. And again, the reason is because they provide an optimized way to store and interact with these vectors. To do that in like a traditional database, there's a lot of like math you'd have to code yourself, and it would be very slow. So what a lot of these like databases like Postgres have done with extensions, or these specialized databases, have built it very deep into the code so that it's very quick to rank records by their similarity. So you don't even have to really think a whole lot about this stuff here, which is why I'm not going to spend any time at all on the math, because it's not really that important. If you're using a vector database, they will have search functions that do that for you and just kind of magically handle it.
Cool. Go on. That sounds fantastic.
Yeah, so then the only thing left in the notebook then is to save the embeddings. I'm not going to run this, so there's a couple of reasons why. The first reason is, as it turns out, there are a lot of chunks in all of these files. And the second reason is we actually, OpenAI rate limits you. Even if you're a paying customer, they rate limit you. Do 60 calls in a minute, I believe, last I checked. So what we end up having to do is we'll make 60 calls and then we have to sleep for that amount of seconds. So this takes way longer than it should because we have to rate limit ourselves to avoid hitting OpenAI's limit and getting back error responses. So this takes, last time I did this on this documentation, it took about 15 minutes. So I'm not going to spend 15 minutes of this live stream waiting for something to run. As it turns out, I already have this JSON file nicely built up for us. And so that's what we're going to use. But at any rate, what we would do if we ran that is we would then just dump our embeddings out into a JSON file that we can work with. It's important to note here, if you're familiar with Python, you could also use a compressed format to do this. You just have to remember to load that from the compressed format in the API, whereas we're just going to read the file. So there are loads of ways to store these objects. They can get quite large. As I recall, like these JSON files are in the 50-ish megabyte range. Also, if you're going to use this as a real legitimate service, you might want to consider using a database, especially if you're going to have more than just like the 1,200 odd embeddings that I've got. If you're going to have thousands or, tens or hundreds of thousands, you definitely would want to have a vector database. We're just not going to spend the time required to set one of those up and actually execute with that today. Save this quickly. So the next piece of this then is the API itself. We are using a framework for this called Fast API. It's been kind of my go-to Python API framework now for probably about a year. It's much more optimized than other frameworks. It's faster. There's a bunch of reasons why I like it, but it's also very simple and easy to read and see what we're doing. So what we're first going to look at is the API specification itself, what we've created here, and then we'll kind of dig into the details of actually how we're working with ChatGPT and searching through things and stuff like that. So first thing you'll notice, we have a couple imports. We'll move past that. We have 2 routes in our API. We have a health check route I include in every API I build because I want to know if my API is alive. And then also a route for our chat use case. So we use a couple of things here. We can specify the response model and then the query model, basically. So I'm going to open up our schemas here, and we can look at what we've defined. So we're using the chat request and the chat response objects. So what this says to Fast API is, hey, look, this is the object that you should expect. Fast API will go and generate for us an open API spec with these nicely delimited types for us to see at the in our API call. So this is how we make this API useful to other services, right? In our case, we'll be putting this behind a Mule API to manage it, and then we'll be integrating it with Salesforce. So we have an open API spec that we can manage in Mule. If you were just going to plug this straight into Salesforce, you have an open API spec you can import and use directly in there as well. So it's really important that we clarify and we specify what these are up front. Now, these are very simple objects, right? These have 2 attributes apiece. The existing context has a couple of pieces here, but that's what these are. So this is, let's just say, hey, look, expect a JSON object with an existing context object and then a query. And then you will return, and you should expect whatever's dealing with this API should expect a response string, which is going to be just the output from ChatGPT on the back end. So this just tells us how to handle things, what we're giving and receiving from the API. It kind of specifies the contract, if you will. Another important piece here is then the helpers that we're bringing in. So I have moved all of the OpenAI interaction to a helper file because it is messy and I didn't want it in the main file. But also because it lets me go through it a little bit quicker. So the first thing we'll do is kind of work through this, and I'll explain what we're doing. We'll get to the search function in here, as well as some prompt stuff that we're doing as well, so we can see what's happening. So the first thing you'll notice in here is we have, well, first off, I guess we load the data that we embedded in our notebook. So in our case, I'm using a backup of the stuff I've already embedded, but you would load whatever you were using. We also we load it up, we create our JSON object. Now it's just a dictionary in Python for us to work with. And then we create a second object that is a matrix of just the embedding vectors themselves. So this looks really weird and funky. All it's doing is saying, I want a list of the vectors for all of the items in the database. Right. And then I'm going to wrap them up in a NumPy array. Right. That's all we're doing. We're just creating a list of these vectors stacked on top of each other. So you'll end up with a matrix that has 1,200 rows and I think 1,500-ish columns. That's all you end up with here. The first method then is our embed query method. So this is just the same thing we saw earlier. When a string comes in, we create the embedding and then we return it. So we've covered this already in the notebook. I'm not going to spend a ton of time here. What I am going to do is drop down quickly and cover the bottom function first, because the middle function gets used in here. So this is the function that we're going to call from our main API. You'll see it used here in the API definition itself. We call this function with the string query that we brought in from the API call. So when the user sends a request, they send their little they send a question. This is that question. And then we also have the existing context that we'll default to an empty array, because if we don't have anything, we don't want to do anything with it. This is where we search. So we're going to search through our database for the most similar records that we have to the query that we've brought in. So now we'll come back up to our search function. So our search function here has four steps. The first thing we do is we embed the query. We already talked about what that is. That's the method up top. So I'm not going to spend any time with this. Then we calculate our similarities. So kind of the naive way to calculate similarities on a large list of these embeddings would be to iterate through the embeddings and say, okay, how similar is my query to embedding 1? Okay, get the number, store it. How similar is my query to embedding 2? Get the number, store it. And you're going to do that for all of the embeddings in your database. And then you would say, okay, I want you to sort these in descending order, and I want however many from the top, right? I want the top 5, maybe. In our case, we're going to do the top 10. That's a very naive way of doing it. Although it would work, it would be quite slow. What we're able to do, because computers are very good at matrix math, we can do this all in one operation. So we can say, here's our embedding, and here's our array of arrays that we built earlier. We can do this in one shot. We can say, give me all the similarities for all the vectors in my database, and just spit them out in a single array. So we get back from this operation the list of similarities that our query has to all vectors individually. So it produces the same result as iterating each of the embeddings, but it's done much faster. The next piece we do, this should be top 10. I changed this recently. We're going to retrieve the top 10 most similar embedding vectors, right? So this is a function that lets us do that. We're not going to dig into the nitty gritty of that, but suffice it to say, all we return here is the top 10 vectors and their original indices in the matrix. So if vector 7 is the most similar, what this will give us is the first value in this, the output of this would be 7. It tells us that the 7th vector was the most like our query, so we want to go and find that one, right? In our case, we're going to have 10 values. So maybe 7, maybe 11. You get the idea. The 10 most similar vectors and their associated index will show up in this array. The next step, then, as you might have guessed, is to go to our database and get the original text for those embeddings. So this is why we store the original text alongside the embedding in our JSON object, because we need to be able to go back to that object and say, hey, I know this embedding was very similar to my query. I need to go and get the original text that generated that embedding. We can't compare the text directly, so we abstract to the embedding level, and then we have to come back down to the original text. So we're going to have then an array of 10 strings that are 2,000 characters long, give or take. If you got the end of a file, it might be a little shorter, but we're going to have an array of 10 strings that are, give or take, 2,000 characters long. And then the last thing we do is we join them up with the pipe here and continue on. So the result of the search then is the 10 most similar passages from our documentation to our query.
Well, one question, is the pipe just a character you choose for this, or
Yes.
it is?
It's an arbitrary character.
Okay, perfect.
You can do anything with this. I mean, I chose pipe because for some reason it seems to help ChatGPT distinguish like different passages from each other.
Okay.
So what sometimes will happen is you end up with these 10 things. And if you just glue them together with like a space, it'll be like, oh, this is just one block. It's like, well, no, actually, this is 10 separate blocks that you need to kind of think about separately in that way. I've noticed a little bit of improvement, but yeah, you could use a comma, you could use 3 pipes, you could use, a new line if you want as well.
Otherwise, you might need to specify in the prompt.
Yes.
These are going to be separated by the specific.
Yes, and so we'll see in the prompt kind of what this looks like. But the pipe choice here is a arbitrary choice. It's just something that's rarely used in English.
Yeah.
We don't really use pipe for anything. So
good. That was my question. Thank you.
Yeah, of course. All right. So we've done our search bit, the important logic here that's already happened. So when we do that search, we get back, as we've discussed, the 10 strings now joined by our pipe. Now we need to format our prompt. So this is what we will do here. So let's look at what our prompt actually is. So this is the input to the prompt. We have 2 variables that we can drop in. So when we see that format function we execute here, that's all we're doing. We're just inserting these 2 variables. We give it a basic start off here. So you could do this in a couple of ways. I like to do it in the main prompt because it simplifies how many prompts I have to write. But I know for a fact that OpenAI, when in ChatGPT, in their web interface, they insert this type of thing into a system prompt at the top end. We're not going to use a system prompt. That's an arbitrary decision by me. But in our case, we're just going to drop in this little thing, help it identify itself. From a prompt engineering point of view, there's a lot of stuff we can do that we're not going to do in here. One thing that I have done to great effect is consistently inserting the current time and date. We're not going to add that here. It's not difficult to do. We just don't need to for this. But from a prompt engineering point of view, that lets ChatGPT know that we're in the certain time and date. So if you're asking, for instance, this might be relevant for documentation. Is this feature deprecated as of today? If the documentation says it'll be deprecated as of August 1st, well, today's August 10th. That means it's deprecated. So it allows it to know where it is in time. Otherwise, it'll assume that it is at its latest time that it was most recently trained. And I think that's going to go back. We're using 16K. So I don't know when that was most recently trained, but I think it was end of June, maybe end of May this year. So that's just a little tidbit of advice that I've found very useful. But we inject our context here. So again, that's the 10 little chunks we have. Mm-hmm. And then we have our guidance. So we tell it to use the context that we've given it. I also have it use a little bit of its own knowledge for the reason that we'll see in just a second. To answer the following question, explain all the terminology. So with MuleSoft documentation, it's very common for there's a pretty high bar of assumption for what the user knows. And that's fine for the most part. But if we want somebody that maybe doesn't understand exactly what some of this stuff means to be able to use this bot effectively, we can have ChatGPT explain very common in very common technical terms to the user. So a very powerful use case we've had for this is in the networking space when we talk about how we deploy MuleSoft on the back end in an on-prem situation, and we need to network between the on-prem network and maybe a cloud network or some SaaS services. And there's a bunch of networking jargon that gets thrown around in the documentation. ChatGPT will then say, okay, look, I'm going to explain what these terms are after I've given you your answer. So here's your answer. And then, this term means this, simplified. This term means this. It simplifies it out. And so you get a nice simplified list. That's why I allow it to use its own knowledge. You can, and if you're exposing this type of thing to a customer, I would generally recommend that we don't do this because ChatGPT can go off the rails sometimes.
Yep.
So we don't want to let it do that sometimes. But for this case, in documentation search, this works great. It helps us know kind of what we're doing. The other thing we can do is I've added this. It sometimes doesn't really use this a whole lot, but it has the ability to generate diagrams if it needs to, because it knows how to generate diagrams in different text formats. So it can do like JSON or something like that, but it doesn't really use this very much. And then the last thing we do is we give it the query that we're going to run with. So in our case, that's just the question that the user posed. So that's what this prompt is doing. This is a fairly simple prompt from a prompt engineering point of view. We can make this a lot more complicated. As Julian noted, with prompt chaining, we can do other things too. But that is a whole session in and of itself.
Yeah, that's for another stream, of course.
That's a different ballgame.
One question.
Yes,
you mentioned something at the beginning of explaining the prompt, which is the system prompt. What is a system prompt?
So in OpenAI terms, a system prompt is some initial guidance for the model right out of the gate. So they use it. I don't remember exactly what's in their system prompt. I'm not sure they've actually published it, frankly, but they have something similar to this. I think they may give it the current time and date, some basic information to kind of help the model along. The system prompt is not weighted very heavily in the models processing.
Okay.
So it is an initial baseline. It's think it's something like, you are ChatGPT, you're a chat model trained on X number of data. Your training cutoff date is this. Just like some basic information that's not weighted very heavily. So putting it in here actually helps to weight it just a little bit more. But system prompts, they have a place. I'm just not utilizing them here.
Okay, good.
Does that make sense?
Totally.
Yeah. Okay. So that's the prompt we're using. We're going to come back to our helpers quickly. So then the next thing we do is we build out our object. So if there are 3 roles we've already covered one of them. There are 3 roles for messages to ChatGPT. We have system, we have user, and we have assistant. They do pretty much exactly what you think. So a system prompt is the initialization prompt we've already talked about. A user role is the user of the system. And the assistant is whatever GPT gives you back. So you could do some really funky things with this. In fact, one of the original versions that I wrote of this early on used the assistant. You can inject history to make the assistant think that it said things, which can be fun just from a engineering point of view, but also it allows you to inject, and this is what I did originally, inject the documentation in as part of the previous prompts. So it spat this out before, it now has access to it. Putting it inside the main prompt, I found to be a little bit more effective, but this is how we also pass our history. So we have arrays of these that would be in the history that we would pass down. So if we're looking at ChatGPT, just the interface again, this is what they're doing. they have a large array of these objects that they're just passing to and from the model back and forth. So that's really how it's working for them.
Is
The
there a
next,
limit
yes.
on the number of messages I can submit on their
So
API?
there's not a limit on the number of messages. There's a limit on the number of tokens between all the messages.
Okay.
So we're using, and we're just coming to this. We're using ChatGPT 3.5 Turbo 16K, which is their the 16K token limit. The standard ChatGPT 3.5 has just a little over 4K token. When we talk about tokens, this is important. A token is the piece that the GPT can process. So we take our words and we break them down into tokens. So very simplified. This isn't quite how it works, but it works as an explanation. Maybe the word "the" is, in their large list of words is word number 727, right? Well, we're going to have 727 is the token, not is super simplified. So if there's people that know this well, they're going to be laughing at me a little bit. But what this does is it says, okay, we have this token. That's how many tokens you can send. A token is actually a little bit less than a word. It's about 4 characters.
Mhm.
So if we want to convert tokens to words, it's like a 70 to 80% conversion. So if I had 1,000 words, that's going to be somewhere in the 700 to 800 token ballpark. So a 4K token is a little bit of space, but you're going to run out quickly. And that's for all of the tokens that are included in these prompts.
Okay.
So this entire thing, once the variables are injected into it, gets crunched down to tokens, and then that's the token count for this message. Then the assistant sends us a response. That gets added in. We send back another message. So the total sum of all tokens is how many the context has. We're using 16K. They just recently released this, I think mid last month, I feel like. That gives us a lot of room. So that's why in our helper, we're actually using the top 10 here instead of the top 3, because we have the room to work with.
Nice. Yeah. One comment in the chat.
Yeah.
So you share your insights. I know here at Salesforce on our AI products, we are working on this trust layer, and we are working on that security to make sure that our customers have all the data safe. But for this specific purpose, somebody's commenting, this is all great, but the company's data isn't saved. That's correct?
So this is a great question. OpenAI has amended their policy recently to be an opt-in for using your prompts and your information to train their models. It used to be used to actually not even be an opt at all. They just did it. That was a change relatively recently. I will say, as Julian, you've noted, Salesforce is working on and has done pretty well with the trust layer between them. I know for Einstein GPT, we filter out like sensitive information. If you need that stuff filtered, so like PII or stuff like that is filtered out of prompts. So you can't accidentally send that through. And that's one of the reasons why we're going to talk about managing these APIs with MuleSoft next week. In the case of this specific thing, and for a lot of use cases here, there's not anything proprietary going to or from the model, right? This is public documentation. We're asking questions against public documentation. So there's nothing private to be concerned about from a security point of view. If you are running OpenAI on internal only data, there is definitely something you need to be very careful with what you do. OpenAI claims to be very safe, but as you know, in security, we have to be very careful, even on top of what external vendors say.
Yep, so, of course.
With OpenAI, I would still be very careful sending internal things to and from their models. I know a lot of businesses are running their own or start working on running their own in-house, Salesforce included. So that's really where I think the industry is headed. But for external facing public data, yeah, this is fine. It'll work. There's no risk to losing data in a hack or anything. So
okay,
I hope that answers the question.
And they are asking, if it is the same case with the paid version of OpenAI.
Yeah. So, uh, paid OpenAI is not a membership so much as it is I've used more like a toll on the highway, I guess.
Mhm.
Uh, you don't get anything additionally when you're paid, other than I think the only thing you get when you're paid is you get bumped up the queue for new things, like new APIs. You don't get any additional stuff. You have to opt out or opt in to have your data used now. But that doesn't change whether you're paying or you're free.
Yeah, and there are like two different like subscriptions in there. I have two,
There are a
like the
lot of different, yeah.
ChatGPT Pro, and I'm paying also for their API because I use it a lot. So
Oh,
yeah,
sure. Yeah, I didn't even think about the interface subscription. That's
mhm.
a good point. There is a
Yep,
subscription on that. The API is strictly usage based, so
yeah,
you're paying
exactly.
again per token sent to and from the model.
Okay, thank you very much for all the clarifications. We are super happy with the
Yeah, of
response.
course.
Let's continue with this. You are giving me a lot of ideas for a project I'm working on. So awesome! This is great.
Happy to help. Yeah.
Yeah.
So we've covered the bones of how we're going to do this in here. The last thing we do is return that to the API, right? So we've got now a functioning Python API that we can interact with. So the last step here, and we're doing well. So we're not going to have any time issues. That's great. We're going to boot up our API quickly. I'm not going to worry about what that starting command is. We can answer that question if we need to. But what I'm going to show you now is I mentioned very early on that we were going to have an open API spec that was generated from the code we've written here. And so we're going to go ahead and actually just pull that up. So this is the open API spec that we have for our API. So this is running on my local, obviously, but if you go to the /docs route, you get this. So this it's OAS 3.1. You can get to the JSON itself. We can just pop that up. You can see this. So if you needed to import this into Salesforce or you need to bring this into Mule, this is the JSON you'd bring in for the hosted when you host this in the cloud somewhere. And then we have our routes. So I have the health check route that I created. Yay. Is it running? It's alive. Yay. And then we have the important one, which is the query route. So I
Mhm.
covered fairly briefly the schemas here. And this is what this produces. So if we pull this up over here, make sure I can do this without losing a window. It's the only thing I'm concerned about now. We'll pull up schemas, and you can see our chat request comes with this existing context thing here and our query. So we've defined that here, and it is generated as a schema with an example value, or we can make it a schema if we want, in OAS for us to work with. All the schemas are included at the bottom as well. So we have our schema for request, our schema for response. We have a schema for errors. I also have a role enumerator for the allowed roles that we can send, although I don't think we're actually utilizing this in here. But this is how you would specify a limited set of values. So if you were going to implement this as like more of a chat type interface, you might want to have assistant and user. And so those get used. Actually, they do get used. They get used in existing context here. So you can only send these. If you don't send these, it will return an error to you. This also means that the API does the value checking. Fast API does this under the covers. So we don't have to implement any data validation. If it doesn't come in this format, it will reject it before it hits our code. So it protects us, makes our development life a lot easier. On the code side, you'll notice I didn't write any validation functions or anything. It's all handled under the covers for us by Fast API because of the specs we've defined. So we can just write code based on quote unquote the happy path. We've defined the happy path, and the happy path is the only path that Fast API will allow you to take. So
I
that's how we end up here.
I love it. For the folks that have seen my previous streams, I cover pretty much this Open API application in Node.js with Fastify, and it's pretty much the same, but with JavaScript. I'm liking Fast API so far. It seems pretty simple.
So I see a question about 3.5 not being fine tuned. Yeah, so this is something to note. I didn't call this out. Maybe I should have. When we do embedding, we use the ADA 002, this model here. There are a couple of reasons for this. First of all, it's the model that OpenAI recommends for making embeddings. And they recommend it because the performance difference between this model and the higher powered models is minimal. I think it's like a single percentage point. And the cost is about a factor of 10 cheaper. So for a single percentage point in performance, you save yourself a lot of money. That's why we're using ADA here. We use 3.5 for the actual chat interface. So once we have our prompt, we send the prompt there. I do think you can fine tune 3.5. I would need to verify that though. Let's see here. I would need to verify that ahead of time. I think you can, but we're not using a fine tuned model for this. This is just the standard 3.5 model and the standard ADA model. There's nothing fine tuned happening.
Okay, awesome. Thanks.
Yeah. So we're going to just remove existing context from this because we're not going to have that. But we can ask a question now of our documentation. So, we can ask, let's see. So API Manager in MuleSoft is actually what we're going to see a little bit of next week for how we manage these APIs. And there are some API policies like rate limiting and stuff that are available out of the box. This is very likely not in the original training data for ChatGPT, especially given when it was trained. We've updated our product since the original model was trained, and I don't think they've added a ton of additional data. So this is almost certainly
you are not
not
even saying, you are not even mentioning MuleSoft anywhere in the
yes,
prompt.
exactly. Yeah, there's no mention of MuleSoft. So any product called API Manager in existence, if you were just talking to GPT 3.5 itself, in theory, could be referenced here. We're not. So we're going to run our query quickly. It's going to ask GPT. This can take a couple of seconds. Most of the time here is spent in the generation of the response. And in fact, if we step into our logs, you can actually see. So I'm printing several pieces here. Here it is. Let's see. So you see some prints here. We've done our query. We've got our context. We've embedded the query string. Doing some math. Yay. This is all of the context stuff, all those little chunks of text I was talking about. And then we ask ChatGPT and it prints out our response. So we can actually just go look at our response. So we can see out of the blah, 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 policies include rate limiting, as I mentioned, throttling, I've mentioned, SLA-based policies, client ID enforcement, all of this stuff, CORS. These are all built-in policies out of the box. You can verify this information in the documentation itself, and provides us with this answer to the question. So what this is rendered in Markdown, as you'll notice, and OpenAPI does not render Markdown. So in a UI, we would want to render this properly. But for our purposes, this is the working API we've designed to answer questions based on a contextual set of documents. So in our case, the MuleSoft documentation, but this could be used. I've used it for MuleSoft RPA as well. We have 2 bots running, but you could use this for anything, and you could change out the embeddings, and you can do whatever you like. In our case, again, this is what we're doing, but this is how this works. So this is the back end of the API. We're about out of time, but next week, what we'll see is taking this API, managing it in MuleSoft so that we can do stuff like throttling and rate limiting. We will also see us then bring that API into Salesforce via external services, and then dropping it into a Lightning component so that we can drop it into apps and do all sorts of fun stuff in Salesforce with this now intelligent documentation search. My favorite use for this is like in a chat window for like a service rep.
This is amazing. Sometimes searching for things on documentation, specifically if you have like a certain problem, is super hard. This solves that issue pretty much.
And it's quite good as well at detecting what's relevant. So if I'm
Mhm.
describing a problem I'm having, it's quite good at returning information that's relevant to that problem. So if I even if I don't know exactly what I need to search for, I have found that ChatGPT in this specific use case for MuleSoft is very good at kind of sussing out what the actual issue is and then returning information that would help me solve my problem even if I'm not clear about what my problem is. It's very nice. It's very powerful. We've been
So
using it quite a bit internally.
if you ask something, let's say, like a data wave problem, and the specific solution is not in the documentation, it can infer the solution by,
So it
or
it can infer for debugging and stuff like that. We have done some data weave and it can generate some. We have not set this model up to generate like actually fully functional data weave scripts. That's like a kind of on our roadmap for what we're experimenting with. Partly because I think we'd probably have to fine tune the model to generate
mm,
that.
fantastic.
But if you're having a problem with data weave and you're like, hey, this is what it's doing. How can I fix this? It's pretty good at responding with the solution to that based on the documentation that it has.
Yeah, you need to extract like certain properties from a JSON. I don't know how to do it, and boom, give you
Hmm.
the answer.
Yeah. Yep.
Awesome. Joe, this is great. So what we have to do, I'm asking you, like, get this part of the project on a repository so we can share this to our audience before the next week's stream, so they
Absolutely.
have this and they can like check the code, understand what we did. And obviously you all will need to have an OpenAI API key, and you don't need to pay for it, but you will be rate
No.
limited.
Yeah. So you can go to OpenAI. You can create an account. You can get an API key. I think it's like $15 of free usage in the first 3 months.
Mhm.
I believe is the free tier. So for reference as well, this use case and like this single query costs like uh maybe a couple of pennies. So we're not spending a lot of money on something like that. Maybe even less than that. I'd have to go look at the meters on how much we've done, but we're really not using a lot of usage here for this. Um, so just as a aside.
Yeah, I've been hitting the API in the last 3 weeks a lot, and I'm not even close to a full cent.
Yeah, it is quite cheap
Yeah.
for uses like this. If you're doing prompt chaining like Auto GPT, uh, it adds up quickly, but
Yeah.
not for this.
That's a different story. Okay, Joel, thank you very much. We are pretty much perfect on timing. Thank you for joining us today on Code Live. And we
Of
are
course.
looking forward to have you next week to continue with this project integrating GPT with Salesforce. Any last words for our audience?
Thanks for having me. I appreciate the opportunity. Looking forward to talking to you guys again next week.
Of course, Joel. See you next week. And thank you very much, everybody, for joining me on this Code Live. I hope you learned a lot of all of these OpenAI concepts about embeddings and how can you start building your own chatbot that has all the context to reply for the data that you are giving them in the prompt. We will see you next week to continue with this series. And also make sure to click on the notification bell here in our YouTube channel so you get notifications on all of the new videos and streams that we will be having in the coming future. Thank you very much for tuning and see you on the next one. Bye bye.